Right, so this is a pulley system here, okay, with a heavier weight on this end. Okay, so mass 5 kilograms, the weight is 5g. The weight here is 2g, okay. So the system is released from rest, so naturally then you know it's going to, B is going to pull down, isn't it? So it's going to accelerate downwards, A is going to accelerate upwards. So that you can see then the direction of the string. Now it's a smooth pulley system here, okay, so that means tension is going to be the same throughout, okay, as I've mentioned here, right, called them both T, okay. You also say the string's inextensible, okay, and that affects something else, right, that makes something else true as well, which we'll come to when I answer part B. So in part A, it says find the magnitude of the acceleration of A and the tension in the string. So what we need to do, quite simply, is using Newton's second law, okay, resolve, right, in the direction of motion. So basically resolving along the string, okay. Now if we resolve at A to start with, think about the way the string's going now. Well, the tension is pulling that object up and the weight is resisting it. So the resultant force is T take away 2g. That will equal to then the mass, which is 2 times the acceleration. At B then, well, this time this is heavy, isn't it? So it's the weight that is pulling it down, and then you've got the tension holding it back, and that will equal to mass times acceleration. So these are equations 1 and 2. Okay. And what's nice with these pulleys questions then is if we solve these simultaneously and simply add them, the tensions will cancel out, because if I add them, T and minus T just becomes 0. Minus 2g, add 5g then, and on this side then that becomes 7a, doesn't it? So you get, yeah, well, minus 2 plus 3 is, minus 2 plus 5 is 3. So 3g, so 3 times 9.8 equals to 7a. So a will be 29.4 divided by 7. So if I work that out, it comes to 7.35, not, I've done that wrong, divided by 7 rather, it comes to 4.2. Okay, meters per second squared. So for some reason I typed in divide by 4. I don't know why I was thinking that, but we're going to divide by 7 there, yeah? So 4.2 meters per second squared. What we'll do then is we'll sub it in then to any of the equations. I'd sub it into number 1 here. It's a lot easier. So T, take away 2g, so 2 times 9.8 equals to 2 times the acceleration. Okay, so subbing it in there. So we know the acceleration is 4.2. So 8.4 there, plus then the 19.6. So if I work that out, it comes to 28 newtons. Now, so we've got the tension, we've got the acceleration. In part B, it says, what assumption did the word inextensible underlined in the first sentence enable you to make in your solution? If you remember, I said, if there's a smooth peg or pulley or whatever, the tensions will be the same both sides, okay, of the string, but it's got to be inextensible, okay? It's got to also be inextensible. Now, inextensible means it can't stretch, okay? Now, some strings can stretch. Think about elastic bands, okay? Elastic bands, you're going to give that as a string, they stretch. Now, when something stretches, the acceleration will be different at different points on that, for instance, elastic band. It will be different at the center of the stretch than it is at the end. Okay, you could try it out and have a look at it. But if it's inextensible, can't stretch, then the acceleration will be the same throughout. Okay, so in other words, it's one system. Okay, and the acceleration can be considered the same, and that's why I've got A there on my diagram being exactly the same, and we can solve simultaneously.